Hello, kicking off the 2020 map, 10 multiple choice questions as usual. A square has centre 3, 4, one corner at 1, 5. Another corner is where? Okay, right, working out corners of squares is pretty easy. So we've got the centre at 3, 4. So to get to 1, 5, we've got to go 2 to the left and 1 up. So that takes us to 1, 5. So we can do a similar thing to get the diagonally opposite one. We go 2 to the right and 1 down. So we're just rotating this thing round each time. So 2 to the right takes us to 5, 1 down takes us to 3. Then we want to do in between. Okay, we're going to get a slightly unfortunate symbol here, but it's the way to get to corners. We're just doing this pattern. So now we want to go 2 up, which is going to take us to 6, 1 across, 4, 6, 2 down, 1 to the left, 2, 2. Are any of those in the answer? 1, 3 isn't, no. 5, 5, 4, 2, 2, 2. There we go. So D. Right, then we've got B. What is the value of that integral? And yeah, we can expand that out because it's like a difference of two squares thing, isn't it? So we're going to have e to the 2x minus x squared dx. So we're going to have a half of e to the 2x minus x cubed over 3, 0 and 1, which is a half of e squared minus a third. And then the 0 is going to give us another half, which we're taking off. Okay. Oh, and they put everything over 6. So we've got 3e squared minus 5 over 6, which is D. That was fair enough. C, the sum of that thing equals what? So we do 1 minus 4 plus 9 minus 16. Right, so we're alternating sign on squares, which means we can't just do a simple series on these because we've got weird gaps and multipliers. So what, 1 minus 3, then plus 9 goes to 6, minus 16 goes to minus 10, then we'd add 25 to go to 15. Right, these are triangular numbers. So we want to go to minus the 100th triangular number. So 100 times 101 over 2, which is 50. That's why I was writing a 5 there. I was already thinking about 50 times 101. So 50, 50 minus 50, 50. Okay, largest value achieved by that equals what? Well, we're going to want to get probably, do we want to sketch or, no, I don't think I'm going to want to sketch. I think I'm going to do a 3, 1 minus sine squared. That's got to be easier if we're just looking at a straight quadratic in sine, because we can get a maximum by completing the square. 3 plus 1 minus 3 sine squared x plus 2 sine x. Complete the square on this. Right, I'm going to do this in 2 steps because I don't want to make a mistake with that minus 3. Sine squared x, that's then going to be minus 2/3 of sine x, and we got a plus 4. Minus 3 sine x minus a third squared. So what are we taking off then? So when we square that thing, we're going to get a 9th. Then we're going to multiply that by minus 3 to get minus a third. So we've got to add a third on. And then we've got to add on the 4 that we add. So the most we can get is if all that is 0, which means we get 4 1/3, which is B. Okay, this is going fine so far. E, a line is tangent to the parabola y equals x squared at the point a squared, where a is greater than or equal to 0. So we want the area of the region bounded by the parabola, the tangent of the x-axis. Okay, so a sketch, this is for positive, so we don't even have to care about any other quadrant. As our quadratic, there's some point, there's some tangent, there's the area that we want. That's at a squared. So we need this point, and then we're all okay. So that point, we need the equation of the line. So that would be y minus a squared. Well, the gradient here for the tangent is going to be 2a. That's what we know about parabolas. So we'll have 2ax minus a. So this intersection point is when y is 0. So y is 0, we're getting that minus a squared equals 2a x minus a. Cancel a couple of a's because they're all greater than 0. Divide by 2, add on a. So x is a minus half a, so x is a over 2. So our area then is going to be the integral of our x squared dx from 0 up to a, and then we have to take off this triangle, which is half the base. The base is, well, this is going from a over 2 to a, so it's half of a multiplied by a squared. That's going to be, well, x cubed over 3, so it'll be a cubed over 3 minus a cubed over 4, which is a cubed over 12, which is c. Okie dokie dokie. F, which of the following expressions is equal to log base 10 of 10 factorial? And I've split them out like that. Okay. The interesting, I've got sixes there. Because, of course, if we've got, this is all based on log AB is equal to log A plus log B. So we've got all of that we're doing here. They've kept the 7. So, and these are all to do with 2s and 3s, with the 2s and the 6s. So the 5's going to have to go in there. And so's the 10. So we're going to need the 2, the 5 and the 10. That's going to give us our log base 10 of 100, which is going to be a 2. So it's not going to be A or B because we got a 2 at the start. So we've dealt with a 2 bit. The 7 is going to go into the log base 10 of 7. So it's not going to be E because we haven't got anything with the 7s. So that leaves our other numbers, which are all in 2s and 3s. Like I say, it's interesting they put it as a 6. So what have we got left? We've got 3, 4, 6, 8, 9. So that's 3, 2, 2, 3, 2, 2, 2, 2, 3, 3. So 6 2s. We want 6 2s, 4 3s. So what have we got? That's got 6 2s and 4 3s, and the other one doesn't. So it's going to be C. As usual, the log question is quite nice. All right, so cubic has equation y equals x cubed, well, all of that stuff, has turning points at those points for some d. What is the value of d? Okay, right, this is fairly standard procedure, so differentiate that. Then we need to set it equal to 0, which is going to give us roots at minus b, so minus 2a plus or minus the square root of b squared, so 4a squared minus 12b over 6. And that has to come out then at, what are our x roots? 1 and 3. So that's got to be 2 plus or minus 1 is what we need with that. So a is going to have to be minus 6 in order to give us that 12 over 6 to get the 2. So if we've got that as minus 6 and we need this bit inside here, 4a squared minus 12b has got to be 36. So we've got 4 lots of 36, so we've got to take off 3 lots of 36. So b is going to have to be 9. So that's given us a and b. So we've now got y is x cubed plus, no, minus 6x squared plus 9x plus c. When x is 1, we get that y is 2. So we've got 2 is 1 minus 6 plus 9 plus c. So that is c is minus 2. And then for the last one then, we've got when x is 3, which is a bit annoying. Yeah, that is a bit annoying. So d is going to be equal to 3. So we've got 27 minus 6 times 9, so minus 54, plus 27. All right, so that's all cancelling out, minus 2. So d is minus 2, which is b. Now, a little long-winded, but fairly straightforward. The following 5 graphs are in some order plots of y equals f of x, y equals g of x, y equals h of x, and then the, well, f dash and g dash. That is 3 unknown functions and the derivatives of the first 2 of those functions. Which plot is a plot of h of x? Right, so we've got, so let's just make a note of these here because it's gone off the screen. So we've got f, g, h, f dash and g dash. And we've got a quartic, a cubic, well, that's a negative quartic. We've got a positive cubic. We've got a positive quadratic. We've got a negative cubic. And we've got another negative cubic. So we've got to pair these things up. So the f and the f dash, the g and the g dash, of course, we're dropping a power. So we've either got to have a 3, 2 or a 4, 3 on these. So h is going to have to be one of the 3's because we've got an excess cubic here. So it's not going to be C, it's not going to be A. So what is this one? If we got a negative quartic here, we're going to end up getting a negative cubic. We don't have any choice on that. The positive, the positive quartic has got to go with a positive quadratic has got to go with a positive cubic. So those have got to go together. And then this is going with one of these. So which one is which? So the differential, well, we've got a turning point at 0 there. When x is 0, we've got a turning point. So we'll have no gradient here. So these two must go together. A and E must go together. So the answer is going to be D, because that's the only one that isn't pairing up. So big fat D. Write that in a circle because I circled E while saying it wasn't the actual answer. No, that was a nice question. I like that one. That was different to usual on the graphs. In the range minus 90 degrees to 90 degrees, but not including them, how many values of x are there for which the sum to infinity of all of that equals tan x? Right, so that's helped that they've left out the asymptotes on here. So we've got a definite value of tan x. So we want tan x to equal that. So that's got to be a converging series. So if that's a converging series, it means that 1 over tan x, or the mod of it, has got to be less than 1 for it to converge. So we need the mod of tan x to be greater than 1. The sum of this then, sum to infinity, so I have to write this as cot, I suppose, a over 1 minus r. So cot minus 1 over 1 minus cot is what we've got, and that's got to be equal to tan x. So what's that? That's 1 over tan x. I'm just multiplying across here. Is going to be equal to tan x minus 1. So multiply again by tan x. That'll make that tan x. Take off 1. So that's all equal to 0. And how many values are there? So we just need to solve this. So we're saying that tan x is equal to, well, I'll just go formula. 1 plus or minus the square root of 1 plus 4 divided by 2. So we've got potentially 2 solutions, but we need that tan x has got to be greater than 1 or less than minus 1. So if we were doing, so root 5, bit more than 2. So if we add it on, we're fine. If we take it off and then halve it, that's not going to be, yeah, that's going to be between 0 and minus 1, isn't it, for the negative? Because we're going to have, yeah, 1. Now if we did 1 minus, say, 2.5, well, it's less than 2.5. But even if we had 2.5, then we go to minus 1.5, then we'd halve it, and we're not satisfying this. So it's got to just be the positive square root. So we're getting one solution. Another nice question. They've had some nice thinky questions in this. Consider a square with side length 2, centre 0, 0, and a circle with radius r, centre 0, 0. Right, so we've got a square, we've got a circle, the square is fixed, the circle is increasing. Let AR be the area of the region that's inside the circle but outside the square. Right, let's draw a little something. So we've got a square. So we want the region inside the circle, outside the square. So if the circle got up to this point, we're looking at all of this bit around here. So circle minus square, that is AR. And then we've got BR is the region inside the square, outside the circle. So that if it was the other way around then. So if we had the square with a circle inside, then we'd have that inside the square, outside the circle. So that's BR. Which of the following is a sketch of ARBR? So we start off, we've just got a square. So of course it has to start at 4. They all start in at 4. And then the circle is getting bigger and bigger and bigger. So AR isn't contributing anything. So it's got to be dropping initially because BR is going down as the circle gets bigger. So it's not C. Let's just scroll down, take a closer look at these. What is then happening? Suppose we've got a distinction here. Can we get down to 0 on this? Can we? Because 2 of these are hitting the x-axis and the other 2 aren't. Can we get to 0? So when we've got a square, this is going to be a critical point, isn't it? When we've got that. But so we've got some value here for BR. And then when the circle gets bigger, no, it's not going to hit 0 because if the circle is a little bit bigger than that, like you had that and the circle just crept outside. Now we've got AR is on the scene. We've still got some BR and AR is never going to go back to 0, right? So we can't hit 0. So it can't be B, it can't be E. Right, what's the difference between these? We've got the rate at which these things are increasing. I mean, I suppose we've got a shape of a graph there. If we also go what's happening here with 2, we could just work out what's happening at 2. So when R is 2, we're going to have, so we've got pi R squared is going to be 4 pi, and then we're taking off 4 for the size. No, we're not taking off anything. Oh, we don't take off. Yeah, we do take off 4 for the size of the square. Yes, because it's the area of the circle minus the area of the square. So we've got 4 pi minus 4, and there is no BR, so that's all we've got. So we've got around about 8, which is up here, whereas this is less. So, yeah, I mean, that's going to, oh, and that's going to fit with the shape of the curve as well, because as we're getting bigger, as R just goes on and on and on, all we're getting is this calculation. We're getting pi R squared minus 4. So it's going to look like parabola. It's not going to be having this a positive quadratic. It's not going to be a negative quadratic. So for both of those reasons, it's not A. But they've given us a big difference in numbers there of something around about 8 and something less than 4 when R is 2. So it comes out at D. Right, they were a fairly swift bunch, but I like them. That J was nice, something to think about. I was nice. I really liked H. That was a bit boring, G, but it was fine. F was really nice. E was fine, a little dull. D was a nice fiddly algebra. C was something to think about. Yeah, this is a nice set of questions all round, really. So I like this as an opening bunch. They were all achievable, but challenging, which is what I like in a set of questions. So very good.